Hello guys, Gennady here. Welcome back to ABPKit Dev series, a series in which I share how ABPKit is developed. Today we will continue with, let's say, crazy refactoring, where we want to improve our code and at the same time to help us moving faster. So, in previous episode, we worked with refactoring the bundle filter list loader to have it be a little bit more generic so we can use it in different contexts and also to have a more declarative and more expressive code. Today we will focus on tests and how can we refactor and improve some of util functions that will help us to remove the applications and at the same time to not write kind of the same code again in the future. So let's see what will we tackle explicitly today under the refactoring. So in bundle filter list loader and at the same time for filter list loader, we have kind of the same protocol. Here we load the filter list source and then we have the completion, and for bundle filter list loader the same. And for remote filter list loader, we have the same. And in our test, we need to test the functionality of a function like this. That we give it the source, and then we wait for the completion and assert the result. And of course, in the future, we can have some protocol that has only the completion, no other inputs, or that has 2 or 3 inputs. And writing again and again the same assertion like this one, expect filter list load, and in bundle we have the same. Doing this again and again can be tedious, and let's imagine that we start testing a new component that has kind of the same function, and we write the code, and then we stumble on the fact that we need to test the result in completion. And we see that we should write a function like this. Of course, we can copy paste, move the code, change a little, but nevertheless, this is, let's say, not so nice. We as programmers tend to be a little bit lazy, and this is actually good. We want to do things with little effort. And also another thing to consider when we work with tests, we usually want to focus on what we want to test. So actually in a declarative way, we don't want to spend a bunch of time in building the infrastructure around things that facilitate the testing or that help testing. An example is a function like this. We write it just to facilitate the testing. It's not necessarily, let's say, going on what we test. We will actually want, and it will be very nice when we write the test, to have just already a function just like this, so we can assert what we want. So you already guessed it, that we will want to have a generic function that will help us test any behavior that goes around testing a function that has a completion block, like something like this. And maybe the first thing that came to your mind is, why don't you use a testing library that provides already such a functionality? And you will be right. It depends, of course, on the context. If you want to use a library like this, absolutely no problem. Get what works the best for you. But at the same time, we need to consider the implication of the dependency, because at the end of the day, it's a dependency, and each dependency added to your project has some, let's say, problems. At the same time, also some boilerplate. With testing framework, you need really to understand good how it works. If something broke in the framework is broken, you should wait for new release and so on. So there are the trade-offs. But what we will focus on today is to use just Swift and try to implement a generic function that will help us asserting against our function that has a completion, basically something like this. So without too much or more talking, let's actually get to the work and see where we end up with. So let's start straight away. What we will want, of course, to have a function that is accessible in any test file. So any new test that will be written will make use, or it will be possible to make use of a function like this. So in order to do so, we will need to write an extension over XCTestCase, of course. So let's do it. And yeah, let's how should we call this name? Let's to have like XCTestCase plus operation, because we will run an operation. So whatever, let it be operation for the moment. The name is not that important right now. So we should import XCTest, of course. Then let's write an extension over XCTestCase. Good. So we have already something, and in order to see the reasoning of how we move step by step, let's copy this function and put it here. And for the moment, let's have a testable import for ABPKit, of course. Let's see if it runs, and it should. And then let's actually rename this to be expectOperation, just so it does not conflict with expectFilterListLoad. So we have the expectOperation here, and let's make use of it in bundle filter list loader. Let's say it has an ambiguous functions, but we have renamed it to expectOperation. So now let's have here, or should we do it this here, or maybe filter list loader is a more comprehensive example. Yeah, because we also have the when closure to execute, so let's work with this. So what we will want is to replace this with expectOperation, and actually let's see if what I brought up. So let's change this to filter list loader, filter list source, and filter list loader. So it's good to be used in filter list loading. So let's now change to expectOperation, and we should be good to run this, because basically it's the same function. Yeah, it's all good. So we have prepared the ground to get going and doing some crazy refactoring. So what would we want to do? Well, we have this function that kind of does what we want, but it's very specific to filter list loader, and actually we can say that it's very specific to filter list loader protocol, but even more, it's specific to the load function from the filter list loader protocol. If we would have one more function in filter list loader protocol, with current implementation we'll have to write another expect, because here we specifically target the load from the filter list loader. So what we will want to do is to gradually extract things or remove things from this function, so we can make it more and more generic. So, and we will use this test as an example where we validated what we do actually works. So right now, let's see what can we remove from here. And first thing is maybe about SUT, that we have the specific target against, or we ask for the filter list loader protocol. But do we care actually that much about filter list loader protocol here in this function? Where if we take a look here, we have the SUT and then we have the load function. So we actually work with load function, not that much with filter list loader protocol. So first thing that we can do is to remove the filter list loader protocol and instead ask the function of which we actually make use of. So let's see what is the signature for the load function, and we can ask for this function instead of asking the protocol. So this will move us one step closer to be more generic, and we will actually see in a moment how this will be more generic than just asking filter list protocol. So let's see what is the signature for the function. And let's have, here we have the SUT and we have the load for source function. Let's remove this, and here we should have our signature available. So the signature is a function that takes a filter list source and a load completion and returns void. So let's copy this and move back here, and let's remove here SUT and actually put this function here. We can remove it to be void, of course. Yeah, just like this, and we can rename this the operation, because this is actually the operation that we test. So we can remove here SUT, and let's have here operation and remove for source. So far so good. I think we are good here, but of course we need to change it here how it works. So we need to have here the operation, not SUT anymore. So we need to pass here a function that matches the same signature. What we'll say, we have SUT load, and let's run the test and see if it works. So yeah, all good. So with this change is the fact that we can pass here actually any any function that has the same signature, not only the filter list load protocol, that if other protocol has a function of the same signature, or any class, or maybe there is a protocol with 3 functions and had one function with the same signature as the operation, in this case we can test it with this function, and this is nice. Well, actually we kinda or actually we can test it, but we have something still specific to filter list loader protocol, and this is load result here, and right now there is no reason to have this here. Let's write it as a result filter list, because this is right now specific to filter list error, and let's put this also here. And this is actually the same, because previously we had the type alias from the filter list for the protocol, but now we made it more generic. Let's run the tests again and be sure that we are good. So now we can see how this is more generic. We can test any function that takes a filter list source and has a completion with the filter list. Any function, it's not tied to some protocol. So far so good. Let's take it one step further and think about this source that we pass and this operation. And we can see that this limits us to a function that takes a filter list source input, and then we have a completion, but at the same time, like kind of passing this source here is somewhat redundant. So we just use the source for the sake of passing it to the operation. So it's not of much value here. So a question would be, why should we do that? Maybe we should provide a way to have this input in the context where operation is used, but here in the context of the function, or in the scope of the expect operation, this is not very much of use, and actually expect operation doesn't care about it. We care about the completion. We don't care about everything that goes here. Is there 1 parameter, 2, 3, 0, 100, whatever you want to put here? We care about the completion. So actually let's ask in the arguments what we care about, not for the moment that we have passed. So what we can do, we can remove this from here, because we don't care about other stuff. We care about the completion. This is what we assert against, so no need for the input. And let's remove also this source, because it is no more relevant. Good, and we can remove it just like this. So what we have here as operation right now, as an operation we have a function that takes just a completion. So let's write a function like this, just to be more clear in the form of the function than just rather the signature straight away. So what it will look like? So it will be something like this. Let's say that we have the completion and we get it from here. So we have it like this. And to see that we are not lying, let's see actually the signature of the load function and make sure that it's the same. So we have here escaping, result, filter list, error, void, void. Absolutely the same as the operation. So this means that any function with a structure like this, we can pass it here. Good. So far so good. We ask from the function what we care about, not what, let's say, other provides us. And this is a good overall design principle. When we design some component, you ask for what you need for a specific scope. Don't just get that is something that is general in the application or others provides. So let's see how can we fix this, because right now this will fail because of course it doesn't work because we ask here, not here, and not here. Well, Xcode doesn't help me. Well, thank you. And yeah, we ask for a function which has just completion as an argument. But of course, SUT.load has two parameters. So we have filter list source and completion, and we care just about the completion. So what can we do here? Well, it's basically we need to match one interface to another, talking in OP terms or something like this. But in functional terms, we need to match a function to other function. And in OOP, where we want to match two interfaces, what we have an adapter. So basically we need something like this to adapt one function to other. And let's see how can we do that. And let's write here the operation in other form, and let's ask Xcode to help us on how this would look like. So here we have the operation, we see that it's like this, and if we press enter, we'll see that we will have this, and this is actually the completion. So we can write here the completion. Yeah, good. So let's do the same here. We have the completion. Yes, so basically we create a function that maps the completion to a function with just a completion to a function that in our case is the load filter list, which has two parameters. So let's see how it will look like. We'll have SUT, we'll load for source, and we have this source here. Let's bring it down here. And what do we pass for completion? Well, of course, we pass this completion that goes that we have up top from the function. So we have something like this. Let's run and see if it's good. And yeah, it's good. So here we have an adapter that adapts one function to another. So far so good. Let's see what else can we improve here. And of course, right now we have here the filter list, and we can improve this by making the function generic. Let's try and do so. We'll have here the generic t and this. Let's try and run our test and see that it doesn't work because the assert equal requires t to conform to equatable. Well, let's do something like this, and let's see if it works, if our tests pass. And sure, here I think we should be good because filter list is equatable, so we have the equatable conformance already. And this is kind of good, but there is one small problem, and this small problem, and actually you can say that it's not problem, it's called void. And the void actually does not conform to equatable. If we will have a result and here we'll have void, this will not work because void does not conform to equatable. And void is kind of strange. It does not conform to equatable, but there is a function that can compare two voids. And let's see if we can find this in the documentation. Let's search for equal. well, not like this. Let's see. And here it is. So we have the actual comparison or equality operator between two voids, and of course it will return true, but we don't have equatable on void, but we have a function to compare void. So this is very strange, and in terms of the design, and I know maybe one of the problems that empty tuples you cannot compare tuple, and the void is tuple. Void could have been an empty struct, and then we will have equatable, but we don't. So yeah, this is how Swift is designed right now. So this is one very strange specific. It's not equatable, but you have an equality operator or a function that you can compare to voids. Yeah, kind of strange. So we don't have here, a way to do to make those two to be equatable. So what we can do to assess also for the fact that we can have void as a result, and this can happen quite often. If you write something to the disk, the result we will have result void error because we don't get something back. We just wait for it to complete. So how can we fix this? Well, we should, or at least I don't know what are other ways to do better. I think we should remove the conformance through equatable because it doesn't work in all of the cases, and rather we should provide an API in this function that will or to let the users or the code that will use this function to provide how to compare to success results. So actually, let's write something like this, and we can have here is equal, which takes 1, 2 t's, say, and returns a boolean. And of course, the first will be the result that with the success that we've got and the expected success. Let's inline this. So we shouldn't anymore use XCT assert equal because as it's seen, it doesn't work very well. And actually, let's put this indentation because it was kind of wrong. What we can do right now is to make assert true, of course, and we can write something like this is equal filter list, expected filter list, and we can then just copy or do something like this rather. And let's make sure the indentation is right. Yeah, this always doesn't work. Good. So far so good. We have accounted for void also. Let's write here escaping fast. We have accounted for void or any type that does not conform to equatable, because we maybe we don't want to put the whole type to equatable. Maybe we will want to compare some parts of it and so on. So this is a more generic API that we don't force to equatable, but rather we provide a way to make sure two results are equal. So good, let's see how we can use this. Now I don't want to go to void documentation, but we need to move here, and we will have to write is equal. So we have the function, the equality for filter list, and equatable requires to have the conformers to equal to have the equal function. So we need to pass this function here, and I guess we should be able to do just this, and we should be good because Xcode should be able to infer that we refer to equal on filter list, and just like this is kind of magic. We can say it works. But if we want to compare the two, let's say result, expected result, we can do here whatever comparison we have if we don't want to conform to equatable. But if we conform to equatable, we just can say just this, and that's nice. That's actually very nice. Next thing is that we have here the error, and right now we ignore the error for the failure, and just for the moment we've been, or I've been lazy, and I should, of course, add the test that we throw the appropriate error, not just some errors. So yeah, we should have a way to compare two errors. So let's start by capturing the error here, and let's have here error, and here we should have expected error, and of course we should have a way to compare, and let's try to compare those two errors. We have here error, expected error. Good. And let's see if it works. And of course it doesn't work because error, not that it doesn't conform to Equatable, it can't conform to Equatable. So as it says, is that only struct, enums, and class types can conform to protocol. So error is a generic protocol. We can compare two errors, but rather we need at one moment to cast to some specific error so we can compare. And we can, let's say, compare to NS error. Right now we throw NS errors, something like this, and this. And this will work. We will compare those two. But of course, if we have some custom error, then it will quite not work. And I guess we actually have one. Let's see. Here, yeah, we have corrupted filter list error. Well, inside our expect operation, we have casted to NS error, and this will not work for Swift defined errors. If you have errors with associated types and so on, how we can we compare those? We can't make the decision here. So what can we do here? And of course, you guessed it, we will need to expose the API to let the code that will use the expect operation to provide a way to compare the errors. So we'll have is equal, let's say is success equal and is error equal, or success equality, error equality, whatever name. Maybe we should think of improving this, but for the moment I think it's good enough. So we'll have a function that takes two errors and returns the comparison between the two. Let's use it here. Is success equal? Good. So we can do absolutely the same here, and we'll have is error equal, and we'll have the error, expected to fail with expected error, but failed instead with error. Okay, we can remove this, and we can remove this, and let's inline this, indent this, not inline. Okay, so far so good, and this is good here, and here we have the is error equal, is success equal. We broke some our tests, and let's go fast and fix it. We have here is success equal, of course, and is error equal. Well, in our case, we ignore the error, and what we can do here, we can ignore the error, of course, and return true, that we don't care about the error, and if both failed, then we can return true, and it should be good. Let's run this. Good. And maybe if for the current implementation we want to ignore the error, maybe we can have some default implementation that will ignore the error, or the errors will be always equal. And we can create quick a function like this, and we can say errors always equal, and it will take two functions, of course, two errors, error, and return a boolean which is always true. And we can have it as a default parameter here, and then we don't need to specify it anymore. Let's run it, and all good. So for the moment we ignore the error, but then if we want to actually compare the error and see that it's the correct error, then we need to do something else. And actually, let's do this. What we want? We want to complete with any error. Here we have the any error, and here error, and let's write it actually here. We have error, any error, just like this. Let's put it here. So it is clear we have two errors, and we expect to fail with the same error as the bundle filter list loader failed. Up until now, we just have tested that we expect if bundle filter list loader fails, then filter list loading strategy also fails, but we didn't test that it fails or it forwards the same error as the bundle filter list loader does, and filter list loading strategy right now doesn't have any other specific error, or it doesn't need to have to. Rather, it implies that it should forward any error from bundle filter list loader or remote filter list loader. So let's try and implement this. So let's see what should we have to do. We have here two errors, and but let's actually do for the moment here inline, and then maybe we can extract some useful function that will do the things for us. Let's say is error equal, and let's try here and actually compare. But for the moment, let's see. Yeah, the test will pass, of course. Let's try, because we cast to NS error and it already works. But if we would have cast to a different type, here, let's say that we have the errors, and here we have is error equal, and we say that those are always equal, and of course it passes, but we need to actually compare the errors. So let's do this. So we have error, expected error. So we don't have a way to write just this, because those are error, and this will not work. We'll have an error about that the error does not conform to Equatable. So what we have to do, we have to cast to NS error, and this also. Let's see if it works. And yeah, of course, we need something like this. And it works. We have made sure that we have the same error. If we will throw some different error, I guess, let's try and have some different error. Here, domain, different, and code, whatever, 1000. Or actually, let's write it 10,000, because 10,000. Let's try and run the test, and we should fail. And of course, it failed, because we expected to fail with this error, but instead we fail with this error, which is not good. So we see that our tests or our operation actually works correctly. Let's move back. So here we have the error. Good. So this is kind of good, but what if we have different type of error, and we need to cast to something different? Will we have to write this again and again and again? Can we just pass the type to which we want to cast, and then just let's automatically it should work? And let's try do something like this. So let's write, casted errors, error is equal, something like this. Yes, and let's have here the boolean. Let's have the errors. Good. And we have, for the moment, let's just copy this and have something like this. Maybe we will want to, let's say, guard against, or let's have it as a guardlet, I don't know, to make sure that we don't have any problems. And let me see here. Let's return false. Okay, and here of course we should have something like this. We can just use the shadow, so to say. So we use the shadow functionality that will use this LHS and T's of this instead of this one. And let's make the comparison. Is it working? Is it not? Yeah, this always succeeds, but maybe we will have some different type, not NS error, some other custom error as we have here, like this one. So we will need a type to which we want to cast, and this should be generic enough. Let's write here the generic, and here we should have the cast, and here cast type, yeah, something like this, and we should cast to have this as cast. Let's see if it works. Not very sure about this, and we have here undeclared type, and we should have it here as t. Let's see. Not very sure about this. And binary operator, it cannot be applied because we should have here equatable. Good. So we will require here that we cast the errors, and errors should be equatable. So we will just have to conform the errors to equatable in order to make use of this. So this is good right now, but our isError function needs to take two errors and then boolean. It doesn't know how to pass here the cast type. So actually we need to use this function to create a function like this. So let's do something like this. So this will create a function that can compare two errors. And just like this, we should have here this, and we have the left hand and the right hand. Good. So let's try and use this. How it will look like here. We'll write something like casted error is equal, and we'll have NS error dot self, and it should work. Yeah, the success case work, but let's actually have a failure to make sure that it actually works. So it will actually work if it will fail. Yeah, the tests are interesting, that it works if it fails, and if it doesn't fail, maybe sometimes you will ask that this is strange because it doesn't fail, it's bad actually. So yeah, different 1,000, 10,000, as I said, 10,000 also always better. And let's remove this, and we should see here a failure. Yeah, and that's good. Let's revert back. Yes, and we have this. And maybe instead, if we have a lot of NS error to compare, and instead of writing this again and again, of course, we can have a function that is called, let's say, NS error is equal. Okay, and we can have, it will build, or actually, actually we can have this straight away. It doesn't have to build a new function, just like this. And what we will do something like this and like this. And then in our code, we can have this, because it is basically the same. So this is good. We have here the comparison with NS error. This is what we want to do. And if in your code you have almost or always comparing NS errors, maybe we can put it here, like the NS error, or if you always like ignore, you can put it here. So you can put a reasonable default that most of the time you encounter, just to make the things move faster. So far so good. We've changed a lot, and maybe we can think that we are done, but actually there is one more thing that we need to think of. This is that the fact that we can have functions that can complete not with the result, but let's say with optional error or some other data. It always succeeds, but it always through a completion. So right now this function expect operation is very specific about the result type, but maybe we shouldn't have the specific about the result type. We should have just some generic type that we want. So let's try and do this. We will want to remove here the result t and have just this, and then just this. And here what we will have, we will actually, let's see, here we have the error is equal and is success equal. We shouldn't need this anymore. And yeah, actually let's remove this and remove this. No, actually I guess we actually need this. And here we have t escaping, and we don't need any more is error equal, because this is very specific to result type, and also is success equal is also very specific to result type. Let's change it back to is equal. It's more generic, and is error equal, we don't need it anymore because it's very specific to result type. And what should we do right now? Well, we should bring this here. Well, come on. And we should have something like this, is equal result and expected result. And we can change in the expected to complete with, come on, with expected result, but completed with result. Let's change, and this can go. We don't need it anymore. So as you can see, we should have this function able to compare anything, not just results, or any function that completes not only with results. It can complete with some other stuff. Whatever, I know, optional error, always error, or some data. We shouldn't be bound just to result type. So we have this commented here, and of course right now it doesn't work because we will need here a way to compare two result types. And let's see how can we do this. Well, we'll need a function and have result is equal, of course, a boolean, and here we have the result, and here we have also the result. And of course we need the type of the result, which will be something like this, and it should be also the same. Okay, good. And then we can use this function to forward it here. Good. Let's try and then switch over the results, and it's kind of the same what we have up until right now, and we have what we have here. We have here the success case with, say, LHS left hand value and right hand value, and we should be able to compare the two. And for failure, oh come on, failure, left hand failure, error, actually left hand error, right hand error. Okay, and if we got to default, then it's false, because both results should be of the same type, success or failure. And then we should be able to compare the two here. And what we need the error. If the error is equal, to be able to compare errors, because as you have seen, we don't have a way directly to compare the errors. And what we will do here, we will call this function, actually left hand error and right hand error, and then we will need the same a way to compare the success. So as you can see, we have moved actually the is_success error and is_success equal and is error equal from the expect operation to the result, because it's very specific to the result. It's not about the expect operation. So return, come on, return is success equal, and we should have left hand value and the right hand value, and here return this. Here we should have something like this, and it should build successfully, good. But also, as with this function, we expect to have it in the form of this, not in the form of 4 parameters. So again, we can do something like this. Let's see if it will fit. And remove this. And remove this. We have this. And this. Yeah, let's move this to a new line so it's more readable. Yeah, something, let's say, something like this. Okay, and then what we should do, we should return a function that knows how to compare two results. And just something like this. And well, this doesn't help. Let's intend it back and then move it here. Yeah, good. So we have this function that knows how to compare two results here, and let's make use of it. This is quite of a big change, as you can see, because we made this function generic to compare any type, not only a result. So we don't anymore have this. We have is equal, and we should have result is equal, and we have this, and maybe we can do something like this. So we have less code here. Yeah, and it works, is good, because basically we have the same, but we have restructured the code. And yeah, so far so good, but maybe one more thing that I would like to do, just maybe just for readability and so on, and because why not, is for the operation. If we will most of the time will end up doing something like this. If you have just a function that have just the completion, then we will just forward it, something like this. But we will need to adapt again and again a function like this to completion. Maybe we can have already an adapter that will do something like this for us. And let's write it fast. And an adapter like this is actually will make use of curry principle. And yeah, let's do this. So we need a curry function, which say it will take a function which has two parameters, a, b, and return c, and we want it to transform to be actually to create two functions, one which takes only a and one which takes only b and return c. And we can take it a look at as something like this, as a function which takes a and builds a function which takes b and returns c. And for us is that important we have the function for source and a completion. And we will want to transform it in a way into a function which takes just the source and builds other function that takes the completion and returns void. And this is actually what this does. It's a function, it creates a function that takes just the completion, but then calls a function with two parameters. And we can generalize this with curry. And let's add the generic types. So we'll have basically absolutely the same stuff. We'll have here a, yes, this is the big function, and then other we'll have here b, and we can call here the f with a and b. Good, let's remove those. Let's build and see if it works. of course, we should have here escaping. Good. And now what we can do here, we can write just like this. And let's move actually back a little bit. I forgot what was it's bundled, any bundle. I forgot this, what source was it there. So we can write it just like this, load, and then we pass. And it will create a function with just the completion. And let's see actually that we don't lie. If you write it just like this, let's see what is the signature of the function. And the signature of this function is escaping, completion, and void, which is the same signature as the operation. So as you can see, it transforms a function with two parameters, in this case with a function with just one parameter that matches exactly the operation. And that's good. Let's run our tests. And yeah, it works. So yeah, it was quite a lot, and let's recap what we have achieved today. So we've moved from a concrete implementation of a function that asserts a completion to a generic function like expectOperation that can assert any function that has a completion, just like this, and it can compare any result or value returned by the completion, not only the Swift result type, but whatever, any type that we want. And we also took into account that do not force to equatable conformance, because void type, it doesn't conform to equatable, and it would be impossible to test in that case. And if you have other types that does not conform to equatable, but we know other ways to compare them, we accounted also for that. And then we know that we cannot compare directly errors. We need to cast two subtypes in order to compare those. And we already also took that in account. We can use this. So yeah, this is it. We actually have built a small testing functionality, small testing library functionality, let's say. And yeah, I think this was a very, very good exercise to see what Swift can do and how we can implement our solutions and not just take some frameworks and use what is there for granted, just like this. So next steps will be to use these expect operations in all of the places, and then just remove these, and also for bundle, and see if it works in generic scope, and actually we will use this for later implementations. So this is it. I hope you enjoyed it. It has been quite a lot, but actually very, very interesting. So yeah, see you next time.